Welcome to Chapter 5 notes. We're looking at data transformations. So when we have our data and we want to use this data to predict something, ultimate aim is we want to predict using something that's absolutely linear, straight line, where our r and our r squared values that equal 1. When something's not exactly linear, it's not straight, then our predictions aren't as exact, so the percentages aren't as good. So we want to try and transform our data to be as linear as possible. We want to have our r squared value as close to 1 as possible. So how we manage to do that is we have all these transformations we can do. So this little chart here, once again, something definitely should be in your resource booklet. So when we have some data, we can plot it on a graph, we can have a look at the graph, and however the curve of the data when we plot it, how it falls, is how we choose which possible transformation we do. So let's have a look at how this would work as an example. So what we've got in our statistics, I've placed in this data where list 1's my X, list 2 is my Y. You can go through and change these lists. However, on your exam, you don't actually have enough time to sit there and change these lists. If you are doing this, you're definitely going to run out of time. So you've got to be very careful at the same time that you are remembering which lists is what information. So first off, let's have a look at how linear this information is. So we can go calc, regression, linear reg. Make sure our X list is list 1 and our Y list is list 2. So right here, our R and our R squared values is, our R squared value is 0.91. So that's pretty close to 1. If it was exactly 1, it would be perfectly linear. Our linear regression line would go perfectly over all our data points. So when we click out of this, it actually plots our linear regression line and then it plots our data points. So looking at these data points, you need to compare what this data is to this information here. So if we go back to our data, we can see that it's kind of curving down to the bottom right. There's a slight curve there. So looking at these 4 boxes, it actually falls in this box. So our data kind of curves to the right. So to make it as linear as possible, we can perform these 2 transformations. We can square our Y values or square our X values. Now we're going to do both of these transformations and see which one of these gets our R squared value as close to the value 1. Whichever one does is the one we choose to use to obviously use for predictions. So out of all these transformations, we've got some squares, some logs, some reciprocals, which we use as 1 over. So it might be reciprocal X, it might be reciprocal of Y. So let's have a look at this data that we had on a calculator, which is curving this way. So we know we've got our Y squared transformation and X squared transformations. How we can do this is we use this cal box down the bottom. And in this box, we can put in what transformation we want. So let's try our Y squared transformation first. So in here, we want to square our Y value. So we know that our list 2 is our Y value. So list 1's X and list 2's Y. So we're squaring our Y value. And if you can place that in there and press enter, it squares all our Y values for us. Now this is where we need to start remembering what lists these are. Now let's check to see if doing this Y squared transformation has actually made our R squared value closer to 1. So how do we do this? Calc, regression, linear reg. We want to use our new transformed data. So X is staying the same. Our new Y squared values are in list 3. And go OK. So if we have a look now at our R squared, it has actually improved. We're now at 0.977. So you need to kind of jot that down, keep that in mind for when you're doing all your transformations to come back at the end to use which transformation got us closer to 1. Fantastic. All right, let's now check our X squared transformation. So our X values are in list 1. So we're going to use list 1 and we're going to square those values. So this is our x squared transformation. So let's check to see if this gets our r squared value closer to 1. So calc, regression, linear reg. We now want to use our x squared values. So these values we did in list 4. So this is where we need to start remembering which lists the information's in. And we're going to use our original y values because we're not changing our y's, we're only changing our x, which we keep as list 2. And let's have a look. Our r squared value is 1. So what's actually happened in this transformation is it's turned it into a perfect linear line. It's a straight line. All our data values, our linear regression line goes perfectly over. So in this transformation, we would say that we would be using our x squared transformation. Now, how do we show that? When we do our transformations, this is how it looks. So for example, we chose to use our x squared transformation. We actually put the square in our formula. So we would write it as, there's our formula, and we'd have the square in. If the best transformation to use was, for example, a log y transformation, we write that in our formula, log y equals. Or if we used our reciprocal, so we had the reciprocal of x, you write that in your formula. Now, be very, very, very careful. Make sure you use the variable name. So if we had, for example, our y variable was price and our x variable was age, make sure you write those variables in. If you don't, once again, VCAA assessors are going to mark you wrong. So once you've done your transformations, all right to use y's and x's in your calculations, but your final answer needs to have the variable names in it. There's the information here, how to do those transformations using the cal box down the bottom, and it works for logs, 1 over reciprocals, that sort of thing. Which transformation is the best? As I said, we want our r squared value to get as close to 1. So after you've done all your transformations, some of them have 3 instead of 2. You would then compare all your r squared values. You pick the one that's closest to 1, and then you use that one to use for your predictions. If you are using the square root button, sign, make sure that if you square root a value, the answer needs to be plus or minus. And going back to, if we have log in our answer, it actually is okay to leave it as log y equals, or log price equals. You can go one step further and use the information from one of the previous notes. I think it's chapter 1 notes, how to manipulate a log so you can get the log to the other side. It's not as simple as just dividing. You need to do a log transformation, which that information is in the chapter 1 and 2 notes. But you are able to leave it as a log y as your formula. Thank you very much.